Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on SCR commutation of SCR in Class A and Class B. First, here SCR. First, I will explain Class A commutation. So, what do you mean by commutation? First, commutation means here turn-on process of SCR is known as a commutation of SCR. Now here SCR is a semi-controlled device. So now here semi-controlled device means here we can turn on the SCR by giving, here this is SCR, anode and cathode and gate. So now here by giving positive supply to the anode and negative supply to the cathode, and then here, and when we give the gate pulse to this gate, and then thyristor is in turn on. Turn on is in our hand, but turn off is not in our hand. By removing this gate pulse also, this thyristor will not coming from forward conduction mode to the forward blocking mode. So now here the process of turning off method in a SCR is known as a commutation. So now here this commutation, thyristor commutation, SCR commutation is in two ways. First one is the forced commutation and second one is the natural commutation. If you give the AC supply to this thyristor, that is natural commutation, and if you give the DC supply to this thyristor is known as that is forced commutation. So now here in the forced commutation we have total 5 methods here: Class A commutation, Class B commutation, Class C commutation, Class D commutation and Class E commutation. Under natural commutation we have Class F commutation, total A, B, C, D, E, F under forced commutation, and Class F is under natural commutation. Now here today I will explain only Class A and Class B commutation. First here Class A commutation circuit. So now here this is supply voltage, only plus and minus DC voltage, and this is thyristor T1. Here this is the load. So this Class A commutation is also known as a load commutation. Here this L and C are the commutating elements. So these are the responsible for commutating this turning off SCR. Here how we will turn off this SCR. So here we have two circuits for low values of resistance. So here we will use this R and LCR connected in series. For high value of resistors we will use this this C is connected across the resistor and this L is connected in series. Now here how we will turn off this SCR. So first here initially when you give supply to this SCR, positive terminal of the battery is connected to the anode and negative terminal of the battery is connected to the cathode, and next here when you give the gate pulse to this SCR, current flows in this direction. This is I. So now this I, here we can turn off this SCR in two ways: by giving reverse potential to this SCR, or when anode current is greater than the holding current. So these are the two ways. So in any way we can turn off this here. This Class A commutation is under this category of when anode current is less than the holding current. That I will explain you. So now here if you give the supply and this current is flowing, I0 current is flowing in this direction. Now here if you apply Laplace transform to this one, I of S equals to here R plus, here I of S equals to V of S by R plus L into S plus 1 by CS. So this is the equation. So now here what will happen? Here characteristics equation V of S by S here. So now here V of S by L. So now here S square plus R by L into S plus 1 by CS. This is the current response. this is current response. How this current response? So now here, this is its characteristics equation. Characteristics equation is here s square plus r l r into s plus 1 by cs. So now he is equals to 0. This is the characteristics equation. So now here, uh, s square plus r by l into s plus 1 by cs equals to 0. So now it is in the form of s square plus 2 zeta omega n plus 1 by omega n square equals to 0. Here zeta equals to 2 zeta omega n equals to 1 by r by l, and omega n equals to 1 by cs, omega square equals to. Now here zeta equals to r by l to omega n, and omega n equals to 1 by, this is lc, under root. So now here, to make this system in underdamped, and this zeta must be in between 0 and 1. So now here, the in underdamped system, the response of current, here this is the current should be like this. So now here, this is the current response of this one. So it should be like this. So the diagram should be in this way here. So now here, in between 0 to 1, the current response in the underdamped system, in this current flows from positive, negative, positive, negative, and positive, negative. So now here zeta equals to r by 2 omega l is greater than 1, and r equals less than 1, r equals to 2 omega n into l, and omega l equals to r is less than or equals to 2, 1 by square root of lc into l, and r is equals to 2 square root of l by c. So now this is the equation, is less than. So now here, by giving proper values of inductor and capacitor, we can make this system is in underdamped system. In the underdamped system, the current response is it's like this, and here it is positive and negative, and at this condition current value is 0. So this output response current value is 0, and next after that it is in negative value. It is in negative value means this I naught anode current is less than the holding current. So here we can make the thyristor is in turn off by giving the reverse potential to this SCR, or anode current is below the holding current, then thyristor is in turn. In this way, thyristor is turn off in the SCR class A commutation. And here, another thing is here, the in this way, this is the thyristor turn off time. And next thing here, thus r value equals to less than or equals to 2 into square root of l by c. This is most important. And next here, that ringing frequency equals to omega naught equals to pi by omega naught, that equals to pi by 1 by root LC, that equals to pi by square root of LC. So W naught equals to. And next here, next category is the class B commutation. The class B commutation, so we will use supply, and what are the commutating elements? So C, and this is the C, this is the L, and this is the diode, this is the main thyristor T1, Tm, main thyristor, and this is the auxiliary thyristor, thyristor TA, and this is the load. So now here we have two assumptions. First assumption is here, load current is I naught is constant. So I naught is constant means this load is highly inductive. And second condition is LC circuit. This LC circuit is resonating in nature. LC circuit is resonating in nature. And third one is here. So initial capacitor voltage is Vs. So now how this initial capacitor voltage is Vs, that I will explain you. So first here, initially this initial capacitor voltage Vc equals to Vs, that I am explaining. So initially that capacitor voltage is like this. So now here plus. So now his current initially Tm and Ta is off, and this is load current, and this current is flowing from this positive terminal to this one, and next here current flows to the capacitor and inductor and diode, and next here flows here, and next it comes back to the negative, flows to the load and negative. And here capacitor charging here. So capacitor is charging, and this potential capacitor is charging when it is reached to the Vs, when it is reaches to the Vs. And so these terminals are this initially it is minus and plus, this terminals are plus and minus. So now here in this case this diode is in reverse bias condition. So there the diode is in reverse bias condition. So now this capacitor voltage is Vs. So these are the three assumptions. First one is a load current is constant, that is load is inductively highly inductive, and LC circuit is resonating in nature, and this capacitor voltage is Vs. So initially it is minus Vs, and after charging, and when it is reaches to Vs, and this capacitor voltage terminals are plus and minus, and this diode is reverse bias. And next here, so now I will turn on the SCR. So first turn on the SCR. So turn on the SCR means this is TM, and this is L, and this is C. And turn on when you turn on the SCR, current flows from in this direction, and this is I naught current. So this current ITM current is also same I naught. So current flows in this direction here. So now current is flowing in the flowing in the thyristor, and current flows to the load. That current is the I naught. Now to turn off, I want to turn off this SCR main thyristor SCR. So for this turn off the SCR, I am turning on auxiliary thyristor. I am using this auxiliary thyristor. This is the I naught. This current is the ITM. So ITM current is also same as the load current, that is I naught. So here I have turned on this SCR. So now this circuit, turn on this circuit means this is acts as a short circuit. Short circuit means here it acts as a LC circuit. This voltage is Vs, so plus and minus, and this voltage is Vs, so it acts as a LC circuit. LC circuit is resonating in nature. So we know this, in the resonating in nature, current flows in this direction. Current flows in this direction means here already capacitor voltage is Vs. So this voltage, this here current discharges here first, and discharges here, and it stores in the inductor, and after that it charges here. First discharges, and because of this capacitor it again it charges. And here in this case, so this capacitor terminals are minus and plus, and here in this case this TA is turned off because of reverse potential across this this auxiliary thyristor. So now here for that case, here this TA is off. TA is off position, and here TA is off position means this is minus and this is plus, this is Vs. So now here this is here in this case. So now here it is turn off means it is minus plus means this diode is in forward bias condition. Diode is in forward bias condition means this is ITM, and this is I naught, this is IM, ITM, this is the load, and current flows in this. And here another current is flowing from capacitor, inductor, and this diode. And this diode will select the least resistance path. It avoids the path going to the load, and it flows in this direction in the opposite to the this main thyristor turn. And now here this ITM current is the anode current. So that is, this current is flowing through this one, means this current is below the holding current. So this current ITM current will decreases. So ITM current will decreases means when it is when this current is below the holding current, this thyristor TM is in turn on. So in this way, in the class B commutation, thyristor will be in turn off. So now actually what will happen in the class B thyristor? Initially, first there are three assumptions. First one is the load current is constant, that is load is highly inductive and this LC circuit is resonating in nature. And next here this capacitor voltage is Vs. So now here plus and minus, and now here start turn on this SCR TM, and after that current flows in this. And next here to turn off this main thyristor, turn on this auxiliary thyristor. It acts as a LC circuit and resonating in nature. This current flows in this direction. After that, this current is discharges through this TA and flows in this inductor. Inductor stores the energy again. This it delivers to the capacitor and it charges here. And this is minus and plus. And in this case, so this is minus and plus means this voltage we are applying to this auxiliary thyristor, auxiliary SCR, and we are applying reverse potential means it will be turned off. After turn off, this is minus and this is plus means this is this diode is in forward bias, and current again another current path flows from this diode, and this diode will not go, it will not select this path, it avoids this load current path, and it always selects the least resistance path. It goes in opposite to the main thyristor. Now here in this, the current is flowing this in this direction means this main current direction will this main thyristor current will decrease means when it will go into the holding current, and this thyristor will be in turn off. So now here if you see the waveforms, so if you draw the waveforms for here, these are the waveforms. First one, gate current, this IT gate current, IGM, that is gate current, and next this IGA auxiliary thyristor, this is TA. So this auxiliary thyristor TA, this is TM, and gate current, and this load current I0, and this ITM current. So this current is ITM main thyristor current, and next here capacitor voltage VC is equals to, and next capacitor current IC. So these waveforms I am going to explain here right now. Now here first to turn on. So we know the assumptions, I0 is always constant and LC circuit is resonating in nature, and here and capacitor voltage is initially charged to Vs. So that we will see when you turn on SCR, this main thyristor. So what will happen here? So now here this load current is always constant, that current is I0, and next here ITM current is also same, that is also I0 current, and after that VC current. So this VC current is the initially capacitor voltage is the Vs voltage. So this voltage is the Vs voltage, and this current is here initially this current value is 0 because when it is open circuit. So this is in reverse bias means this diode is in reverse bias means that current is 0. So now here when it is open circuit, so now here this is now it is conducting only TM. So now to turn off this TM, so this auxiliary thyristor must be turned on. So now turn on this. This is T1. This is TA is on. So sorry, TM is on. Tm is on. So now T1 is TA is turned on. So now here in this case, when TA is turned on, so what will happen here? So now this capacitor discharges, this capacitor current discharges here in the negative, and that current equals to that current is the capacitor equals to IC current equals to minus ICP sine omega t. So ICP means here Vs square root of C by L sine omega t. So now here that capacitor current first, here this is load current is constant as it is, and this one this current is also same I naught current. So this current is also same I naught current, and capacitor voltage is initially Vs is it is discharging. So voltage is discharging means voltage will decreases to zero first. Voltage will decreases to zero. So this voltage is decreases to zero. This current is minus ICP sin omega t, and next here this current is negative maximum value. Here this is minus ICP. So ICP. So now again when it is current flows through this inductor, and inductor stores the energy in the form of magnetic field, and when this voltage is zero, and this inductor will delivers the voltage to this capacitor. This inductor will delivers the voltage to this capacitor, and again it will charges. So again it will charges. So now here this this capacitor voltage is in this. So now here, and this current will increases and it comes to the zero. So now here it is plus and it is minus, means this value, this capacitor value, this for diode is in forward bias condition, means diode in this is minus and this is plus, and so here this thyristor will be turned off, means it is open circuited and it is zero, and this voltage is here minus Vs. So this voltage is minus Vs. This voltage is minus Vs. This voltage is minus Vs means this diode is in forward bias condition. So this is T2. This is T2, and this is when TA is off. When TA is off. Now here what will happen? This current flows from capacitor and inductor, and this diode is in forward bias and it goes in this direction. So now here at T3, so now here this current flows is in this direction, means here this load current is as it is, and next here this load current is same, and this current will decreases. So this capacitor current will increases in positive direction, and next here this main thyristor will decreases. So the main thyristor current will decreases, and next this current will go up to VAB. So this is VAB, and this one will go to the passive. So when it is will be decreases, so it is going in this, it is increasing and it is decreasing. So the main current is decreasing and this capacitor current will increasing. So this is up to T3. This is T3, and when thyristor will be turned off. So here it will be turned off, means here at T4 it will be turned off, means here the main thyristor current will be zero. It is turned off means that acts as an open circuit, and this value is it is again maximum Vs, capacitor voltage is Vs, and next it is maximum, and next here it will comes to the current value is 0. So in this way class B commutation. So here main reason is here to turn off this SCR auxiliary thyristor, inductor, capacitor and diode we will use. So now here we have some questions here. Voltage across the main thyristor when it gets commutated, and the circuit turn off the time for main SCR and conduction time for auxiliary thyristor. So now here this is when TA is on, and when TM is on, TA is off, on, and TA is here off, and TM is off. In the previous case also this one is off. So now here this is T1, this is T2, this is T3, and this is T4. So now here we know the here up to this, here this is VAB. So this is voltage across the main thyristor when it is the turn off. So now here VAB equals to, that is minus VAB equals to VS sine of, sorry, VS, actually voltage across the capacitor is VC equals to VS cos omega t. So now here Vs cos omega t, here this time period is here pi place. This one is here up to here. This is up to here. This is pi plus cos of pi plus omega into T3 minus T2. Omega, this is pi up to here. This is pi. This is T2 and this is T3. Pi plus T3 minus T2. This duration. Now here this one is here Vs minus VAB Vs cos of here this one equals to minus of Vs omega t T3 minus T2. So now VAB equals to Vs cos of omega T3 minus T2, and omega not T3 minus T2. How we can calculate this one equals to sine inverse I naught by ICP. That means here sine omega T3 minus T2 into ICP equals to I naught here. So that current is here, that is I naught. This capacitor current equals to, that is maximum current, T3 minus T2 equals to I naught. So now VAB equals to this Vs cos of sine inverse I naught by ICP. ICP equals to here Vs square root of C by L. So this is the formula. So now here this formula equals to VAB equals to, so Vs cos sine inverse I naught by ICP. So circuit turn off time for this main thyristor is here. So turn off time of SCR means the time for which the SCR is in reverse bias. So don't consider reverse forward blocking mode time. So only when time for which the SCR is in reverse bias condition. That reverse bias condition means here that is here the time is minus VAB to 0. This is reverse bias condition, minus VAB to 0. So now if you the minus VAB to 0, V of t dt is equals to 1 by C integral of I dt. If you simplify this circuit turn of time t equals to C into VAB divided by I. So this is circuit turn of time for main thyristor. The conduction time for this one is the pi by omega naught, that equals to pi by 1 by square root of LC, that equals to pi into square root LC. So these are the main formulas. In this way, in the class B commutation, the SCR, the main thyristor, will be turned off. I hope all these concepts of class A and class B commutation concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. hit the bell icon for more updates.